Hi, I'm Kelly Beall. I'm a primary guide here.
Hi, I'm Kelly Nguyen. I'm one of the elementary guides and also the admissions director.
And I'm Emma Rodwin, and I'm the intermediate program director.
And we're going to talk to you about mathematics. So in the primary environment, we are preparing the child from their very first time in the classroom for math. And when I think about the math area and what we offer to the primary child, I feel like we respect them so much because we're giving them these big numbers and we're asking them to do operations, right? Like addition and subtraction and multiplication and division. But it's because the primary child has, well, really every child has a mathematical mind, but the primary child has an absorbent mind. So they're in this perfect place where we can offer this to them and they can take it in and they can internalize it and they can understand it and feel confident in themselves using these big numbers, and then they take that with them for hopefully the rest of their lives, right? It sets them up for feeling comfortable and confident in their math skills, which not everybody has. And so my goal is to offer them an experience with the math materials that really help them to love math and to feel good about sitting down with the math work and doing it independently. So we prepare them with things like practical life, sensorial, and language. So all the work that the child does leading up to the actual math material is preparing them for that mathematical work. And it's small things like the order in which we set up wood polishing. We set up in a very logical left to right order, which helps the child to organize in their mind, which they need for math. They're going to be setting up number cards eventually in this way. We want them to see those patterns early on. And sensorial, every material in the sensorial environment, if you've ever seen it, it prepares a child for math. It's exact, it touches on volume, and we've got different shapes that we bring in, and it's such a beautiful area, and it prepares them so well for the math material. And we really want the child to use those materials a lot before we offer them the math material. And we want them to be able to carry the largest red rod across the room without, knocking anything over or maybe hurting a friend, right? And we want them to see the patterns too. That's really big. The sensorial patterns that we create from the pink tower all the way up to the decanomial square will help the child in the math area. So once they've had all of that preparation and we've given them language, we've given them scientific language, they're prepared for the math material. And we begin with group 1. And so in the math area, it's broken down really nicely. We go from group 1 to group 6. And we begin with numbers 1 through 10. So we have a really concrete initial correspondence, right? We're showing them the quantity and the symbol, and we put all that together. And then eventually the child will go on to group 2, where they'll use the decimal system. And they're here for a while because it's a really big and fun, exciting time for the child. They're using numbers all the way into the thousands, and they're doing operations. And very often these are children that are around 4 and a half. And so I always am so impressed and so excited for them when they get to that place because they've been watching the older children do this and add all the 1,000 cubes together, and now they get to do it. And so that group is important and they're there for a long time. And around the same time that they start group 2, they can start group 3, which is teens and tens. And in our classroom, we have a beautiful bead cabinet, which carries on to elementary, and they get to count and label. So that's really where they get to practice that really important work. And so from there they go on to memorizing their math facts, which is important again for later in elementary. That flows right into there. We want them to have those math facts in their mind, and they'll revisit it when they start to abstract the information, which is the next group. So they have all of it in their mind, and then they can start to do operations on paper. And that's really where independence is coming in again. They're taking all that knowledge and they're using it to complete these big operations on the big bead frames, and that's another elementary material. So we have a lot of crossover when we get to that category or that group, which is really great, I think. So it really shows the foundation of those prior groups and how it sets them up for that 5th group. And then the final group, which is one of my favorites, is fractions. And it's so fun, and I am always so excited when a child gets to fractions, and it just really rounds out their whole mathematical experience. And we step them off, and I think they're pretty set up for you guys.
Yeah. Just like so amazing hearing you talk about it because there is so much crossover. You don't really think about it, but the end of the primary math is basically the beginning of the elementary math. So if we don't get to it in the primary, we'll definitely get to it in the elementary. And if you didn't get it, if you're in the elementary and you're not working at the same pace everyone else, that's okay, because that's why we have the mixed age classrooms. So every child can work at their own pace according to their own interests. And of course, I can talk more about why Montessori is the best, but let's go back to math. So all of the foundations that they receive in the primary will continue to build on that in the elementary. So when Kelly was saying they work with numbers to the thousands, into the thousands, we're working with numbers into the millions now. So they take the same concept and we just stretch that decimal system out a little bit more and we go into the millions. The operations, they're working with the operations, 4-digit plus a 4-digit. Now we're doing 6-digit plus a 6-digit, or 7 digits, or however much they want to. And what I really love about elementary is they love big numbers, and they want to work with as big of numbers as they can. And you kind of see this at the end of the primary too. Like, I love seeing the thousands chain stretched all across the hall, and maybe they don't always get to the 1,000 at the end, but they're counting each bead and they're labeling all the tens, right, until they get to the thousands. And this actually is preparation for one of the work that they do in the elementary, which is concepts of squares and cubes. And I never realized this until I took my elementary training, but when you square a number, you get a square. And when you cube a number, you get a cube, right? And this was mind-blowing for me, but because the materials are so concrete, you can see it, and you can touch it, and you can feel it, the children can work with these abstract concepts very easily, and it's easy for them to understand because they can see it. Oh, this is what it means to have a 2 square. That's why it's 4. We have 2 2s, 2 rows of 2s, and that equals 4. And then if we stacked 2 of those on top of each other, we'll have 8. So it's just amazing because they can then start to memorize these, and then we can do operations with exponents, which I don't think you usually would get to it until you're in middle school or high school. This past year I've been really into square roots and doing the algorithm, so figuring out how to do square roots with numbers in the millions just on paper. But of course you have to start with the Montessori materials first. We do pre-algebra, solving for the unknown. We stretch more of the fractions. I think in the primary you work mostly with equivalents. Do you do some operations too?
We do. Yep.
So then we stretch that more. So instead of working with just same denominators, then we'll start teaching rules for, well, what if it's 1/2 plus 2/4? What would that look like? Oh, they're not from this, they don't have the same denominator. What do we have to do? How can we find an equivalent fraction so that we're able to add these together? And eventually they can do it without the materials. And then in math, we also go through geometry too. In Montessori, it's 2 separate subjects, but I think for this purpose of this video, geometry, so we talk about the different shapes, we go into volume, like you were saying, and area, and then figuring out the algorithm or the formula for finding area of different shapes and volumes of different shapes. And all of it is sensorial. You get to touch it, feel it, see it, and that's how you learn best.
And like in the primary, where there's that crossover between the primary and the elementary, where they're doing a lot of the same math as they shift between those planes of development, the same is true from the elementary to the adolescent. So a lot of that work with pre-algebra and solving for the unknown, that just helps to bring this math forward into concepts of algebra. And again, if they didn't get it in the elementary, they'll just get it in the adolescent. But when we talk about math in the adolescent, we talk about the fact that math is kind of like a 3-legged stool, right? Where you have each leg is a different branch of math, and one would be arithmetic, one would be geometry, and the third is algebra. And so we often remind the students right at the beginning that they have spent all of their years in the primary and the elementary getting very, very good at arithmetic, right? They can add, they can subtract, they can multiply, they can divide. And often by the time they get to they should be by the time they get to the intermediate program, they can do a lot of that abstractly. They can do it on paper, sometimes they can do it in their heads, but they don't have the same kind of reliance on the sensorial materials that maybe they did when they were 6 years old. But there's this new branch of math that maybe they were introduced to a little bit in the elementary, and that is algebra. And that is a new thing for them to conquer. And so we spend 2 years in the adolescent program with them really getting the foundations of algebra. We do have some sensorial materials that they love to use because it just reminds them of their primary and elementary days, called Algeblocks, which again, it's a physical representation of X or Y, or the unknown. And they're very good at working with those. But more and more of the work is on paper and abstractly in their minds, with graphing and solving equations and things like that. And some students may even move quickly enough that they are getting to geometry as well, and that is building on everything that they have learned. Actually, Montessori kids know way more geometry than your average student. So by the time they get to geometry at the level that it's being taught in middle and high schools, they're like, I learned this when I was 7. So they really know a whole lot about that. And I really think that throughout all of the levels, you can see that the children love math. They're excited by math. It's not something to fear. They're puzzles to solve. And so whether it's arithmetic or geometry or algebra, they have this great love of math and seeing math in a real world context. So not only are they maybe doing problems out of a book or working well in a classroom, which of course they can do, but they can see math as it applies to their everyday lives. I need to measure something to build something for our greenhouse. Well, I'm going to be using math for that. I'm cooking lunch for 20 people in my classroom. Well, I'm going to be using math for that as well. And this love of math and seeing the way it shows up in everyday life, I think prepares every student, no matter if they go into a field that requires a whole lot of math or they don't, right? Everybody at some point in their lives needs that kind of appreciation for math as it shows up. So this is how you see math at all 3 planes of development.